Welcome to the Convergence Podcast. I'm your host, Ashok Shivanan.
Do you have repetitive knowledge work? And if you have repetitive knowledge work in your organization, that is often a ripe candidate for creating some sort of agentic application that can disrupt or automate that human process.
On this show, we'll deconstruct the best practices, principles, and the underlying philosophies behind the most engaged product teams who ship the most successful products. This is what teams are made of. I talk to a lot of CEOs, product leaders, and founders, and a lot of them feel like their companies are getting left behind in this artificial intelligence race, and are having a lot of trouble getting started and doing something about it. Hey folks, welcome back to another episode of Convergence.fm. Today, I'm joined by my good friend, Austin Vance. Austin is the CEO of Focused, and they've built a number of production agentic applications. And I get to talk to him and unpack the real world journey of building these agentic applications and how to get unstuck on getting started on leading your company there. On the episode, we deep dive into how to pick the first AI product at your company, why repetitive knowledge work offers the best ROI, and how to avoid the trap of doing AI for AI's sake. Austin shares tactical frameworks, case studies across multiple industries, and architectural patterns that help scale simple AI integrations into fully agentic systems. Whether you're leading your company through an AI transformation, or you're leading a product organization or an innovation lab, this episode lays down the essential roadmap to building AI that actually makes progress for your customers, your team, and your organization. Now, we got so deep into this conversation that our team decided to split our conversation with Austin into two separate episodes. Today, you're listening to the first of the two episodes, where we focus on identifying the best AI applications to get started and how to architect and deliver the applications. On the second of the two episodes that we'll put out next week, Austin is back and he'll talk about how to drive AI adoption on your team, the culture, the craft, and what leaders like yourself need to do to unlock the hidden potential on your team by harnessing AI. Here's the first two of the conversations with my good friend, Austin Vance. Subscribe to the podcast to get future episodes as soon as they're published. If you find this helpful, give the podcast a 5-star rating on your podcast app or hit that like button on YouTube. Welcome to the show, man. I'm super excited to talk to you about building agentic apps.
I'm great. I'm super happy to be here. You know, we go way back, and I want to talk about building agentic systems and apps and all that kind of stuff. So let's go.
I want to start with maybe helping folks out there that are feeling the pressure of the world being taken over by AI, or at least feeling that way.
Yeah.
And wanting to implement something internally at their companies. And maybe they've kind of gotten to that point of like approving the team's licenses for ChatGPT for their talent. But they're really thinking about, hey, it's more than using this for operations. It's for using it to build better customer experiences, build better apps that are AI powered.
Mm-hmm.
And I know you've worked on a couple of these, many of these at Focus. So help us with for that person looking to build their first app, where do they start digging to pick the first app that probably makes sense?
Yeah. So when I think about all right, so there's multiple tiers of building AI. And first, maybe I should ask, are you thinking about a developer building an AI app, or are you thinking about a developer using AI to help them build, the CRUD app that they've been working on for a while?
The first of those, hey,
First of those.
maybe we've got data, maybe we don't. As a business, I want to get good at creating better applications, maybe better customer experiences, differentiating our products because it's powered by AI. And I'm not sure where to get started on learning, and maybe I'm overthinking it, maybe I'm not. where do I start kind of turning over rocks where I find something that makes sense to get started on as our first AI app as a business?
Yeah, good question. I am like super anti uh, AI for the sake of AI. There's a ton of stuff that you can do with traditional software that you can build, you know, that you can inform and just build. So we have a customer and they have a whole bunch of call centers, and they, first go to is how do we use AI to make our call centers more efficient? And actually what we learned from them, I know this is not answering your question, but I think it gets you there. What we learned from them is like a bunch of the calls were really basic, like information gathering. And so instead, the first thing we did, rather than saying, oh, let's build a chatbot or a voice agent that can like intercept calls and answer these questions more efficiently, it was like, well, all these people are opening a mobile app to get to a button to click to call us. And we know that they're asking the same like 6 questions. Why don't we just present that information to them as they go into the mobile app, and we can front run? And that's just like traditional software. So first things first is like think about the user experience and how AI will increase or detract from the user experience. And in this case, like still forcing a person to call uh, doesn't actually increase that customer experience. It doesn't make it easier for them. You might see the same operational gains, but you don't actually like move the needle for the customer in the same way. Because it's like, okay, now I have a voice agent who says it rather than a real person. So I can make my call center is more efficient, but I still have customers complaining that they have to call to find out, basic information like my opening hours or something like that. So the first step is, where does software solve the problem? And there are places where AI actually is better. And the critical hat I always apply to it is, where in your organization do you have repetitive knowledge work? And if you have repetitive knowledge work in your organization, that is often a ripe candidate for creating some sort of agentic application that can disrupt or automate that human process. And then the human that used to do that repetitive knowledge work will direct a team of agents that are doing that, rather than them doing like one task at a time. They will have, 5 agents doing these tasks 5 at a time, and they will come and step in the right places where the knowledge work is too complicated, requires human oversight, something like that. So that like, where is the repetitive knowledge work in your organization is great. So if it's exposing opening hours via phone call, that's not repetitive knowledge work. That's like information. That's an information architecture problem. If it's uh, answering questions a customer has about how, I don't know, say you're a moving and storage company, about how, pick up, drop off, loading, and scheduling work, and people ask those questions in a dozen different ways, it might be easier for an AI to answer those questions. And then that's a really nice place to do it, because like a FAQ doesn't get you there. It doesn't give that like kind of personal touch. It doesn't give specific answers where an AI could.
So repetitive knowledge work, I like that, and I'm going to make some assumptions. So hold me accountable, keep me honest here.
Yeah.
The knowledge work implies that the folks who are doing it today are likely pretty expensive people that are doing it, and then the repetitive nature, you're kind of multiplying these expensive hours by something that's happening pretty consistently. And so in terms of
Yeah.
chances of having a high ROI, it's a high cost that you're going after today that likely make it a good candidate. Am I understanding that correctly?
Kinda. I don't know if they're high cost people. A lot of times it's similar roles to what people might want to outsource from their company. It's not core business process, but it is like repetitive things. And these roles tend to scale with your business linearly. So like I scale, if I'm claims processing for insurance, the more customers I have in my insurance company, the more claims I have to process, so the more claims processing agents I need. And so I'm scaling that. But my first line of claims processing agents might be fairly low trained employees. It's very like, here's the book, here's how we process it. You look through, contractor sends a invoice, you look through the invoice, you look for some key points, you negotiate on those, and then you return. So like, that's a really nice place for an agent to go, where traditional software might not have been able to do that, or it would have been it is more cost effective to just have humans do that. But those humans could be anywhere. They could be, employees of your organization or not. That's that first tier of repetitive knowledge work. AI can push up that chain pretty effectively, but it requires more and more human observation the higher you push up the chain, and it will start to, like, I have an email agent that drafts responses to all the emails in my, it sorts filters, and I built this thing, but I don't let it send emails unless the email asks like for an opt out. So if I get a cold email, it's like, and if you don't want to hear from me, respond opt out. Like, so it knows to look for like that kind of stuff. And then it'll respond with whatever key phrase they need. And it'll auto send that, but it doesn't auto send anything else because there's like, I need my voice and like, I want that. So those are places as you push higher up the knowledge work, you might want personal touch still in your organization, but it cuts substantial time still by just automating process, right? The sorting, the filtering.
Yeah, and I know both of our companies have worked on autonomous vehicles
Yep.
in some capacity, the other, and help companies, our customers, with that. And maybe a similar analogy there, where the companies who were like fighting to have fully autonomous and having the first reveal of anything being that 0 to 1 found it really hard compared to the ones that slowly tried to automate parts of the job, like lane assist or assisted cruise control, where the human was still intervening. It allowed you to get the product out a lot faster, and maintain safety while you got better at building the product. So I'm hearing a similar analogy here.
Yeah, and they build it, like you said, it builds on itself. Exactly. So like I can automate a very simple process with artificial intelligence. And then I like look at, okay, what's the next set of things? And I automate that. And then I automate the next process and I automate the next process. And the hurdles that people run into inside of existing systems is these agents have to integrate into the legacy software that exists, but it has to integrate with the existing systems of an organization for it to be valuable. If an agent just kind of like hangs out, consumes a bunch of documents and then can deal with that, that's great. And it might be able to front run some customer service calls. But then if it can start submitting, follow-ups into an existing ticketing system, if it can see Slack messages to, and send those to the right people, if it can update databases. So if I can like call in and read off my employee number to an AI agent, and then I can tell it like, hey, I'm on my way, I'm late to work. Like those types of things get super valuable. But the integration becomes the complexity of that system. And that's when you start moving up the chain as well. So that's how you start. You find something with low integration, low grade knowledge work, and then you start to integrate more deeply into the systems. You give it more control, more tools. And as you learn what the agents are capable of, you start to build out what they call a graph or an agentic network. And then it can start to make decisions, work with itself, to make those decisions, hand off to different agents that are better or worse at certain things. And a lot of this stuff, frankly, can be done without, how do you say it? Without, like fine tuning or like training. A lot of people are like, oh, I need to fine tune a model or I need to do that. Like you don't need to do that if you kind of know how to architect the system and build the guardrails in appropriately.
Interesting. A few things to unpack there. And the first place I want to start is to add to that checklist that you brought up. Where does access to data come into play as you're starting to evaluate what the first app might be?
Yeah. So we will often start building like agents that have read-only access to data. And they're fairly good at, large language models are incredible at adding structure to unstructured data. So say I'm a large law firm. This is another kind of case study we have, but like a large law firm with gajillions of pages of discovery. So I have financial statements, I have text messages, I have emails, I have, business plans, I have PDFs and slide decks. Like LLMs are really good at combing through all of that and finding connected meaning. And so we give read-only access to sets of data. And there are patterns, like that's the RAG pattern, but like the retreat, you can give access to the LLM to that kind of stuff. And you say, okay, what is valuable for the LLM to know so it can answer back? So if I'm a law office and I have all this discovery, I might be asking, hey, when did, this person contradict themselves? And that's a really abstract question. And before, what I would have done, like think of that repetitive knowledge work, is I would have had a legal aid read all of this stuff they'd read through gajillions of pages of text messages and financial statements and all that stuff. And they'd be looking for and they'd be like, oh, I remember when, Kevin contradicted. He said this in a text message that he was going to he promised to pay the bill. And then a month later, he said, screw you, I'm not paying. So now we have a contradiction and we can go dig into that. An LLM can find that, but where I paid a legal assistant to do that spend months reading through, an AI can find those things in seconds.
I'm going to try and oversimplify it into a checklist here. So
Yeah.
repetitive knowledge work. So that legal aid going through, reading more and more stuff while holding context, having access to data set, even if it's read only at first. And then finding something that maybe doesn't have to integrate with too many other systems.
Yep.
Gives you a few things that allow you to get started first, and not having to integrate is there's a number of image-based AI apps where you can take a photo of your room and say, hey, I want to see this in a mid-century modern design. That's easier to do than saying, hey, this is something Crate and Barrel's putting on, where you can click on different products now that are shown in here and go buy it, which requires a whole different set of integration and an order of magnitude of complexity.
Yep. So find repetitive knowledge work that is mostly read-only. So check. Then automate that knowledge work based on the read-only. And then figure out where those people were writing to the system. And then start to automate that. And then look at the next tier. So then those group of people were doing repetitive knowledge work, what was the next tier of people doing with their work? So if I'm that law office, I'm drafting a brief. Can I start to pre-draft the brief with AI? Can I highlight potential arguments from the contradictions I found, right? So then we're going up a level, right? And so you look for that next piece of repetitive knowledge work.
I love that. And we'll make sure to have that summarized as a checklist for folks looking for where to get started. And I think Focus has worked on something that kind of checks all those boxes there, right?
Yeah. So, the legal assistant is a good example. One other one, in a lot of cases, these AIs, they do things that traditional software cannot do, or it would be very expensive and very difficult for it to do. So one customer we have, they're called Hamlet, and they are they're like a government transparency project. So they work for real estate developers, or their customers are real estate developers and political action committees. And what we do is we consume incredible amounts of local government meetings, think county level, city government level meetings. And a lot of these places, because of COVID, started putting those meetings on YouTube. And what we want to do is as we consume all of these things, is we start to ascribe policy changes, zoning changes, all of those things to individuals. And so we take video content, extract audio content, and then label who's saying what out of these meetings, which would be really abstract and really difficult to do in the past. Think if a LLM if a meeting's happening and I'm hey, Kathy, what do you think about Prop 293? And then somebody speaks, next. And traditional software would find it really difficult to say, oh, I know that's Kathy, because they could be introduced to know. That was a good point, Bob. Really hard to do that. But through an LLM, we can start to give confidence scores to each speaker and then ascribe, policy changes through time to each speaker. The other thing we can do is, if a government meeting, they're talking about, I don't know, zoning, rezoning or gun control or something like that. The way people would search for this before, and I can tie it back to the repetitive knowledge work too, but the way people would search for this before is with keyword search. So I would still transcribe all the meetings, which is not the hard part, but then I would search for the words like gun control. But what if no one ever says gun control, but they're talking about how AR-15s are totally different than hunting rifles, right? And handguns. And so that still is thematic of gun control. Large language models do a really good job of finding thematic similarity between things, so you can search and find even more. what these people used to do is they would literally send like a task rabbit or a low paid employee into these government meetings, and they would like listen to them. And so you'd have a person sitting in a meeting at a county office, listening to the rezoning meeting, listening to a city council meeting, and then texting or writing a report saying, here's what Kathy said about gun control, here's what Mike said, here's what Tim said. And like that has imperfection and it doesn't scale, right? If you want to scale that across a whole country, or you want to scale, it it just doesn't work. Where this AI is super efficient at doing that.
I can think of at least 3 layers of using AI here. And a lot of folks listening probably have seen like the Zoom call transcript,
Yep.
which is taking the language spoken and then transcribing it to text. And that part's easy because Zoom knows which one Austin is and which one Ashok is.
Yeah, it has like multiple audio streams, so it's actually very
Exactly.
easy.
And then the next layer is there's probably a discernment in terms of our voices, but I guess kind of confusing when you got 6 people in a city council meeting or more. And then so you're using cues like people's names, and that's a super clever use. And then the third one, of course, most folks familiar with an LLM are familiar that it can work with themes rather than specific keywords now, where, like you said, if it's talking about AR-15s and gun control, and you ask a question about gun control, it will parse the stuff that has related themes, all coming into one super clever application. And then, of course, saving a whole bunch of time and effort that you previously have to hire a human to go sit in, that comes with variability, cost, and other ways that you can't scale.
Training and all this other stuff and lack of scale. Yeah. It is that. And that like that semantic or thematic search is actually another place. I just popped in my head is another place you could get started with large language models. It's not necessarily an AI based application, but that if I run a search team at a company, so I don't know, I'm working at Wayfair, just a random company, right? And I have my search bar. I could start to layer in like semantic search, which is large language model powered. So then when I search for sofa, like I'm looking for, what are the key themes that sit around sofa? Like there's love seats, there's sectionals, there's all these other things where they might have built a knowledge graph at Wayfair already that connects them. The language models actually can have that. And so I can get those themes out of a more human or natural search. It used to say that like you kind of built a skill in how to Google because you like, and now it's like when I search with a language model, I almost want to forget the skills I learned to search with Google and ask things like a human would ask another human.
You mentioned the term graph or agentic network before.
Yeah.
So maybe give us like a relatively layperson definition of what that means. I think it's pretty foundational to building an app, right?
When you think of how like decisions are made, there's often like a standard operating procedure. So like this, this thing happens, then this thing happens, then this thing or this thing could happen. And then you check the work and maybe go back to the beginning. And that could be like how I have my CS rep, my customer service reps, like handle a support ticket. The exact same thing exists inside of agentic systems. So agent is a really loose and definitely a buzzword. So my definition of an agent is a large language model that can perform a task autonomously. Not a lot of tasks, but a task autonomously. And so I will give and create a series of standard operating procedures between different language model calls that it can then do something. And that something can be read or write. And that is the graph. So think in the case of we worked on an AI therapy application, and we have this large routing network inside of it. And we can talk more about this later, but we have this large routing kind of agentic network inside of this therapy application where different parts of the LLMs are specialized in different therapeutic techniques. And so we have a supervisor agent that kind of looks at the messages coming from the user and what they're working on. And if we're dealing with stress and we want to work on breathing exercises, we would route those calls into another agent that can understand, breathing exercises. That then can have the app create reminders to do your breath work every, few hours and like interact with it, or can, use retrieval augmented generation to pull up a video and expose that to the user about how to deal with like stressful situations. And that is this graph of like, one thing decides, oh, this is what the user's talking about. Another thing says, okay, I want to deal with it. Another thing says, here's how I want to respond. And then that response gets routed all the way back to a user. In more complex systems, maybe an agent is calling a tool. So you'll see this when you, like, if you're a layperson using ChatGPT now, I ask it a question. Like if I say like, when is the 2025 Super Bowl? It's going to like execute a web search, because the large language models are trained on data that's, is outdated. Like they have a date cut off, so it doesn't know. So it's going to execute a web search. So that's an agent going to the internet and saying, I'm, Googling or using a web search to look for when the next Super Bowl is. I read a handful of web pages. I process all of that. I searched 10 pages. 8 of them said it's on this date. This is the date, and it returns with that answer. So that's what an agent or a graph is.
Fostering an engaged product organization and aligning them with the principles around lean, human-centered design, and agile will more than likely lead to successful business outcomes for your organization. But getting started or getting unblocked can be hard. This podcast is brought to you by the player coaches over at Integral. They help ambitious companies like you build amazing product teams and ship products in artificial intelligence, cloud, web, and mobile. Listeners to the podcast can head on over to integral.io/convergence and get a free product success lab. During this session, the Integral team will facilitate a problem-solving exercise that gives you clarity and confidence to solve a product, design, or engineering problem. That's integral.io/convergence. Now, back to the show. I do want to zoom back out and go back to kind of where to get started. And I think we're going to dig a little bit more into the technical side. And there's 2 things that come to mind. And the first one is, I think there's still people who are not using ChatGPT at work for whatever reason. And, we'll maybe get into the Shopify memo that is, almost like an ultimatum to folks who aren't still adopting it. The fact of the matter is, I think there is a customer audience that's probably going to overlook some of the challenges associated with using LLMs because they understand the underlying value. And I imagine that maybe comes into play as well when we're picking and choosing which apps can be more AI apps or which ones can be more automated compared to like the repetitive knowledge work.
The best AI application, so like put not using ChatGPT aside, the best AI applications, the interaction with the language model. So if it's Gen AI, so we'll use like not traditional ML, but Gen AI applications, the use of Gen AI is transparent. Chat is a terrible interface for interacting with LLMs. It's a really nice one for ChatGPT because like that's its product. But everybody was like, oh, I'll add chat to my app. And that's not the most powerful case for Gen AI applications, and it is not the most valuable case. And a lot of times it is off-putting to a user if I'm like, I'm in HubSpot and now all of a sudden instead of generating a report, I have to like chat with it to generate a report. It's like, okay, this is not what I'm trying to do. Now, if HubSpot can be intelligent about how to highlight the reports that it thinks are meaningful to me, they can use Gen AI to create those queries. They can use Gen AI to understand. Like that becomes very transparent to me, and that gets valuable.
Given this opportunity to have all these different models that you have to choose between, and your team has built a number of agentic apps, what does that model selection process look like? That's probably something that is fairly arduous and new, maybe compared to traditional software.
It can feel fairly daunting that there's like a bunch of models and they have different cost structures and they have all this like different personalities, different strengths and weaknesses. We use an abstraction layer called LangChain almost all the time. And that abstraction layer lets us write agentic code separate than business logic, separate than the large language model integration. So if I go and I work directly with like the OpenAI APIs, I am locked into OpenAI, and the switching cost gets harder and higher and more difficult. And by using LangChain, which is essentially the best in class like agentic open source agent orchestration framework, we are able to swap language models or add new ones in lines of code and minutes. Now, what then becomes super important, and is important no matter if you're integrating directly with OpenAI or you're using LangChain and have the ability to swap models, is having really strong eval frameworks. So eval is this idea. So if you're familiar with test-driven development, I know you are, but if your audience is familiar with test-driven development, it's this idea of having a desired behavior of a system that I assert of that system before I even have the system do anything. And so the exact same thing is true about a language or a large language model based application or an agent. And I want this agent to be able to do something. So given a series of inputs, it should give me these outputs. Large language models are different than traditional software because the results are non-deterministic, but you can still design them so that they give you the right result. And you need inside of a continuous integration process, you need inside of a continuous deployment process or an iterative, building process, the ability to assert that your application, your agents, do what you expected no matter what. Evals are the process of designing inputs that test the boundaries of what you think the language model is capable of or should be doing, and then sending those through your prompts or through those models, and then asserting that the output is correct. And if I then switch from ChatGPT to Claude to Llama, if I go from ChatGPT where all my evals pass, but it's too expensive, so I want to switch to Llama and Grok because I want faster, cheaper, and my evals all still pass, I can have high confidence that my system still works. If my evals are failing, maybe I need to go iterate on my prompt. So I go iterate on my prompt until my evals pass again. And this has been a super important part, like the most critical part of developing these applications. We built a AI therapy application, and it's I talked a little bit about it already, but it's this like large agent network. And one of the things that's out of scope for this therapy application is self-harm. It needs to deal with self-harm in a very specific way for legal purposes, but also just because like that's a very serious topic. That's different than, hey, I'm trying to get through a stressful situation at work, or I want some coaching on how to have a conversation with my partner about, some boundaries or something like that. Self-harm, it's like full hard stop. We do not cover that topic. We refer you to self-help hotlines, or we give you a real therapist that's part of the app's network, that kind of thing. And so we built a massive eval set. And as we're iterating quickly on the prompts, the design, the different stages of therapy, the different checkpoints we can have, we would run the self-harm like eval through all these prompts, through different models. And we were actually able to switch from Llama 3.1 to Llama 3.3, and then try Llama 4, and like do all that stuff very confidently that our self-harm, safety checks all still passed always.
And this sounds like the type of thing that maybe folks are forgetting to do that leads to AI making up policies that are fictional, and then the lawyers, the accountants are still on the hook for paying the bills and or kind of going to court, right?
Yep. And there's like, it's so funny. I do think that if you're going to build agentic systems that automate this knowledge work, they're held to a higher standard than like a human employee. It's the same as like we talked a little bit about autopilot. If autopilot crashes one car, it's like we should be banning autopilot, but people crash cars all the time, right? Because you have this accountability question that happens when you start making like autonomous decisions coming from machines. And so building in that strong eval is super important, and it's not an easy problem to solve. And it like I said, is the lion's share of the work that we do. And it's very easy to build a language model application or an agent that does something and demos very, very well. But without a good eval framework, they can make pretty substantial mistakes. Like you said, like inventing, I think it was like Air Canada. Was it Air Canada? Do you remember? It like
I think Air
invented some
Canada had
customer
like a
service
bereavement
policies.
policy or something like that. Yeah,
Yep.
exactly.
Even Cursor, which is like a AI native IDE, they had like a customer support bot go off the rails and tell people that a policy change meant that they could only use one computer per subscription. And so they had a whole bunch of people canceling. Like these are things like it's very simple to move fast, but you will break things. And it's the same reason when I write tests in traditional software. So like I'm building my test suite. The reason I'm building my test suite is uh, to give me the ability to change my software with impunity. So if I have a strong test suite, it gives me the confidence that me refactoring, building, or changing the structure of the code did not alter the behavior of the system. And the exact same thing is true with a strong strong eval framework. I can refactor my prompt, I can add things to it, I can change it, or I can change my agent network. And because that eval framework is there, I can change with impunity. I know that I did not change that outbound behavior of that system. And that being exceptionally strong, and your development team, your business team, your executive team being extremely confident that the eval is correct is the beating heart of the ability to change a large language, like an LLM based application or a agent system.
And so I could use your advice here. I know that when it comes to test-driven development, there's an art to determining what is a useful test or the incremental value that this next test brings. A lot of it is maybe software best practices. And if you're an experienced engineer, you kind of have a sense of things that will go wrong on a unit test or on the technical side. Some of it is having really strong conversations with the domain experts and trying to understand, like in your case, self-harm is something that's particularly more sensitive compared to a boundary setting conversation. And so when you're coming up with what kind of tests go into an eval framework, I imagine that there's a trade-off of having too much stuff in there will slow you down and make you super inefficient rather. And then on the other hand, you need to make sure you have the critical things in there so that you can deploy and iterate confidently, knowing that you're putting safe applications out there. So how do you go about having that conversation of knowing what's the right size of what goes in the eval framework?
I think you nailed it. It's a combination of understanding the true business requirements, so asserting that the business requirements are met appropriately at every stage. And so, what are the business requirements of an application? When I say click reset password, it should be sending me, password reset email. That's a business requirement, right? And so I assert that that would happen. In an LLM, when I ask it, what time is my next flight? I would have an eval that knows how to check, a database for when my next flight is and return with that appropriate information. And I would have that assertion. So you're building that eval at the same time. The second stage, and this happens in traditional software too, and if you build great software, you can build great agentic systems. The second step that happens is observability. So let's go back to traditional software. I release into production and there's like this build, deploy, learn cycle that like lean brings you, right? So I build my software, I deploy it to production, I learn what's happening, I see the bugs, the edge cases where people get confused or using it. And so the same exists inside of large language models. I need to know how people are using these things. And because the interaction patterns are a lot broader than the interaction pattern of like a web form, because it's natural language in English, or say we're only using English, but language is naturally imprecise. I need to know how people are talking to my system and how it's responding. So layering observability into your language model and your agentic applications is the second step in that. And then you'll start to look at the observability, and we actually use language models to judge the responses in production, saying, did this act appropriately? Did this act appropriately? Yes, 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 no. And we look at like, okay, someone asked this question in this way. The LLM got confused. So now let's go and build a test case for that so it can respond appropriately the next time. So that gets added to our data set. It becomes part of our eval framework, and that becomes part of our future, kind of deployment process. Similar to if there's a bug in production, the first thing I'm going to go do is I'm going to write a test that reproduces that bug. And then I'm going to go fix my code to fix that bug. I watch that test pass, and then I push that to production.
And I'm trying to understand how far in the future we are here. That last step of understanding that the observability has kicked off something that didn't pass and then adjusting the prompt. How automated or manual is that for an engineer to do today?
We're mixed. We use a framework called DSPy a lot. And so DSPy is trying to figure out how to describe it in like very layperson terms, but it's essentially like a prompt tuning framework. And so you can say like, given this input or these series of inputs, grade the output, and then like keep changing the prompt a little bit until you get the best. So we'll automate some of that. But then often it is a person coming in and saying, hey, we noticed it responded this way when asked a question. We noticed the LLMs are responding inappropriately or incorrectly when asked a question in a certain way. And so I'm going to go and like add to my prompt, never ever use emoji, because I'm an AI therapist. And for some reason, at this time, the thing is like trying to use emoji. And then we'd have
the crying
eval,
emoji when you're actually crying is probably
right,
inappropriate.
exactly. And it's like giving you the mind blown emoji or the poop emoji or something like that. Like you'll have a human build the data set or we'll use the production data as the data set if it's appropriate and the privacy policies allow it. Otherwise, we'll recreate similar. And then we will build, test, and eval to assert that the system responds appropriately based on that data.
You touched on a very important point around security and privacy. And I think that's maybe one of the big friction points around adoption, as it almost always tends to be. I think the non-deterministic nature of LLMs makes it even more of an enigma, and the friction is even more frictiony. How do you coach your team? What are maybe some internal guidelines or policies to really reduce the probability of challenges around security and privacy?
I mean, different industries and different practices have different requirements and comfort with privacy and security. And so first is understanding the domain. And so if I'm a travel booking app, I might be completely okay with, a handful, if not my entire small engineering team, having access to production logs. But if I'm an AI healthcare app, I want to have rigorous HIPAA compliance, and only a certain set of people can ever see that information, if anyone. And so then we need to figure out ways to extract meaningful data out of it. This is a problem that exists in normal software development too, though. And that's normally the conversation is like, in traditional software, like who can go into the database and see like PII or PHI? And what is the audit process for that? And how do you make sure that we understand that those people are using that data appropriately? And so those same things all apply. There's always question about, especially if you're sending it to a third-party foundational model, so like to Claude or OpenAI, what are they going to do with my data? And the same is, I think, security officers are getting more and more sophisticated, but the same is true. Like if I host my database inside of Amazon, like it's on Amazon servers, it's on Amazon disks, it's in Amazon's four walls. Like who can see that stuff? Of course, Claude, OpenAI, Google all have enterprise agreements that guarantee security, and they'll sign BAAs and they'll do all that other stuff for HIPAA. And that's one way. The other is, you can run all this stuff yourself. There's a huge open source community, and some businesses feel much more comfortable or find it more appropriate to operate and run their own models. And the open source models are nearly as powerful as the closed source models. Sometimes they lack or they lag a little bit, but not by long or not for long and not by much.
And if you want a cloud version, and in between, if you want a cloud version of the open source models, what does your team tend to use?
Grok. If it can be hosted not inside of like AWS or something like that, there's a GROQ, not K. It's like a little confusion. The GROQ is they're like a high speed inference. They run open source models. And then if we need it to be inside of like the AWS infrastructure, inside of VPC, we either deploy our own models into SageMaker, or we would and run them there on GPUs, or use like an Amazon Bedrock kind of thing.
It's interesting that you bring up Grok, GROQ. They build their own chips. And, currently with tariffs and everything, I think it's also coming to the surface a lot more that their chips are built in the US.
Woo!
And speed and cost are big differentiators, despite kind of being US made, which is not something you hear for a lot of things. So how much of a difference does speed make in the user experience?
It's so funny. It depends. For some applications, like we're used to ChatGPT. So a lot of people don't realize that like when I ask ChatGPT a question, it's like pecking out, it looks like it's like typing on my screen, pecking out characters. That's actually how fast it's responding. That's not a user experience. That's not like some animation. It is like the large language model is deciding the next, word or two that it should respond with kind of in real time, and you're seeing that happen. And users have started to see that it responds at just faster than most humans read. And so it's normally okay inside of, even a ChatGPT, which is slow, is normally okay, for like a call and response or QA style application. Now that gets really painful when you start to build agents. Because like when I talk about agents, I talked about this graph, right? So I might have one agent that calls something, and then it gets a response from an LLM, and then it asks an LLM to do something else, and then it asks, I have 3, 4, 5, 6, 7, 8, 10 calls to different LLMs before the user ever sees a response. And that's just like a spinning wheel, right? Then speed becomes super important. And this AI therapy app is super funny. Like, we switched it over to Grok, and it is so fast that we slow it down to make it feel more human.
Experience?
Yeah,
Wow.
It's crazy.
That I didn't think I'd hear of that anytime soon.
Yeah,
you got to actually. It's so fast. You got to slow it down because
like it feels inauthentic. Like it's like
yeah.
I'm like, it says to you, "How are you feeling today?" And you say, "I'm feeling a little blue," and it's just like, tell me why you're blue. And it's like, it's like that's too fast. And so we want it to kind of like,
is this a rules engine?
Right. Exactly. We want it to have a little bit more delay. So there's perceived thought, but it's executing the exact same on the Grok GROQ chips. It's executing the exact same thought process as it would have, anywhere else. They're just faster. And so that worked really, really well. It was kind of funny that we were like, I think we need to slow this down.
There's obviously a lot of cost benefit associated with using Grok, then not just the speed in that case where it continues to make sense, right?
Yeah, I mean, it's we saved thousands and thousands of dollars a month for this startup. And they're a very young startup, but in inference costs by switching away from where they were hosted into Grok because of the API pricing that they have. I don't want to. I'm happy to be a Grok ad, sponsored by or whatever if you're looking for that. But it was a very easy switch because we were using LangChain, and we had good eval, and the speed and cost difference like blew the CEO's mind away.
Yeah, I'm glad that you brought those points up because similar to the kind of product side of things, I did want to get sort of a checklist that I wanted the engineering leaders to be self-assessing on. And I heard so far, making sure to have a good abstraction using something like LangChain so you can swap out your models and not get tied into any specific vendor like OpenAI, for example. I heard about an eval framework and thinking through really what high quality looks like and what kind of tests you want to put in place. And then observability was the other thing that you mentioned. Anything else that, is on the sort of running checklist amongst your engineers around architecture, making sure that you're applying all your best learnings into the next app you're building?
When we build any agentic application, we apply the same level of software engineering rigor that we would to building traditional software, like a React app or a Spring Boot app. And one of those things is we try and decouple, like, yes, we want to use the abstraction layer like LangChain, but we want to decouple the business logic of a LangChain from the LLM orchestration. And so similarly, like in a Spring application or a Spring Boot application, I want to decouple my business logic from like the Spring Boot router and all that kind of stuff, because then I have more control over my business logic. So for an engineering leader, thinking about how and where the boundaries of your language model applications fit is really good. Agents use this thing called tools. When it goes and searches you see ChatGPT go search the web or generate an image, what they're doing is they're calling a tool. And building those tools in test-driven, highly crafted software ways is very important. And then using an eval framework to then get the LLM to call those tools in the appropriate situation is also very important.
When you mentioned in that therapy app that, you've essentially got like the triage agent that determines what type of problem you're helping the user solve, and then triages it to a specific agent that's more specialized in breath work or hard conversations or whatever else. And then I think there's another element of having multiple models work in the same application that I've coached folks as a reminder that, hey, you don't have to use the same model across your application. Sometimes pitting the models against each other can act as a QA or as a test harness.
100%.
I'm curious what you think about that.
There's two, like one is for very simple task work, we'll use like very fast and smaller models because they're much cheaper. And for like more complex reasoning tasks, we might use thinking models. Some models are better at calling tools, some are better at writing code. And so we choose these models based on their personalities and their capabilities. And yeah, there's actually like a series of papers, and I just published this on X, and my goal is to, and this will come out after today, but my goal is today to record a video of me showing how to build this. But consensus-driven workflows inside of LLMs are actually really powerful. So I will have two LLMs discuss like people. So I might have like Llama talk with ChatGPT about the solution to something, and then they will eventually get to an agreement on the solution to a problem. So, hey, I want to create a 6-month marketing plan. Here's my data. Here's what I'm trying to accomplish, yada, yada, yada. You two argue about it like a small marketing team. And then at the end, write me a marketing plan that you both agree on. And like you can build an agent network that does that, and you kind of get a gut check between the two.
And what's the AI equivalent to like table flipping when they can't arrive at a consensus?
Well, they're luckily very, very pleasing.
So they're more likely to hallucinate than flip tables?
I guess the AI equivalent is a really high inference bill, because they just never agree, and so it just keeps running forever.
Hope you enjoyed the first of these two conversations that we have with Austin Vance, the CEO of Focused. There's a number of insightful nuggets from Austin, and there's 3 things that I'm really hoping you take away from this episode. The first is around how to choose the right first app for your organization. Look for areas in your system where there's a lot of repetitive knowledge work, where you have access to the data that surrounds that knowledge work, and something that doesn't necessarily depend on integrating with an existing system. I think that'll help you go really fast and allow you to get started quickly. The second is that there's multiple layers of using AI, like we heard about in that government transparency startup. They use AI not just to transcribe the meetings and convert the audio to text. They further use AI to extract themes of the conversations versus specific keywords. And lastly, they use AI to assign names to the speakers based on the transcription itself. And this is especially useful since all of the audio is coming in through the same feed. The more you use AI, the more you'll switch to a mindset of finding different ways in which AI can help you build smarter, better applications. And lastly, when you're building AI apps, you want some of the software best practices that you have from traditional software and bring them in here, especially ones that help you and your organization stay fast and nimble. And we heard a couple. One of them is having an abstraction layer using something like LangChain. So you can easily switch between the various LLMs and the models, and you're never locked into every single one where it's expensive and time costly to change. Another is having an eval framework. And this is similar to a test harness, and it allows you to consistently and continuously have confidence and transparency that this application is going to continue working with the safety and quality guardrails that you set, even as you quickly make changes to the models, the architecture, add features. And in addition, this confidence is also going to allow your team to go really fast in the long run. And so I certainly think that it's worth the initial investment and the upkeep of maintaining this eval framework, given that you're able to go much faster for much cheaper and ultimately build better. We'll be back next week with Austin again, and we'll switch gears slightly from building AI apps to building an AI team, fostering a culture of adopting AI. And we also get to hear Austin's thoughts on the leaked Shopify memo about their AI mandate from their CEO, Toby Lutke. I hope this helps you with starting small, starting with yourself, and most importantly, starting now on exploring how your business can make progress by building AI and agentic applications. We will see you next week when Austin returns. Thank you for joining me on the Convergence Podcast today. Subscribe to the Convergence Podcast on Apple Podcast, Spotify, YouTube, or wherever you get your content. If you're listening and found this helpful, please give us a 5-star review. And if you're watching on YouTube, hit that like button and tell me what you think about what you heard today.